Good morning. It's my pleasure to share with you this short presentation on grapevine fertility and yield components. I did prepare this presentation with my colleague Dr. Anne Pellegrino, who is working at Montpellier Supagro. And this talk is part of the session on grapevine pruning. Is part of the session on cane pruning or guyot pruning. During this presentation, I will speak about the concept or the rule of 70-30%. So, I will try to explain what is behind, speaking about grapevine yield component, what is behind the 70 and 30% of yield production. Grapevine yield components, as you know, it's a 2 years story. So during the first year, within the latent bud, the differentiation of what we call the primordia of inflorescences did occur. And then you have winter, you have dormancy, and dormancy needs to be released. And then year 2, at bud break or from bud break onwards, the latent bud is starting to grow. And then this is when and where you have the growth, the elongation of the inflorescences. And on the inflorescences, you have the differentiation of the flowers. And then you have the period of flower fecundations. Because, as you know, for a berry to develop normally, one normal seed is needed within the berry. To make a long story short, this is the 70% part of the yield components. The 30% part is linked to the number of berries and their volume. So from nouaison onwards, from berry set onwards, the yield will be mainly due to the equation berry number and berry volume. And this is perhaps to me the best period to predict the yield. Having said that, and to make a bit of a joke, the best stages to predict the yield is at harvest. So this slide is showing, it's another way to show the 70% and the 30% parts of the yield component. So the blue and the green dot points represent the 70% from bud break to flowering, including flower fecundation, and then from berry set to harvest, this is the 30% part of the yield. And on the right hand side you have a figure which is nicely showing a very good relation between yield in tons of production and the number of bunches, knowing that on those bunches the number of berries are fixed, and then the growth of the fruit is now mainly due to water and nitrogen, to make a long story short. This slide is showing the organization, the morphological organization of a latent bud, and this is an histological section of a latent bud during winter. And then you see that within the latent bud you don't have only one future bud, but at least you have 3 buds. And it's interesting to know that, because if something is happening to the main bud, then, for example, spring frost, which will destroy the young, very young primary shoot, or the principal bud under development from bud break onwards, then it's possible that the second bud or the tertiary bud will go under development. Of course, they are less fertile, but still it's better than nothing. And on the right hand side, you see a cane or a vine which is bleeding. This is what we call in French les pleurs de la vigne, and this is due to the fact that before bud break you need to have the right soil temperature and the right air temperature to break what we call now the eco-dormancy. And when the root starts to function again, then it's possible for the latent bud to start their development. Interesting here to understand that while the primary shoot is growing, then at the axillary of each leaves you have a future latent bud. And at flowering, we know that, or we have observed, that the very first bottom latent buds are already differentiated. I'm speaking about the 1, 2, or 3 first very bottom latent bud. So around flowering, around pea size, you have already done the differentiation of the bottom latent bud, which represent the next year crop. Obviously, the climatic condition and the vine physiology will matter for the yield components, and we already know since many years that bunch and canopy microclimates are very important for the differentiation of the latent bud, and the main abiotic factors which will affect the differentiation of the future latent buds are the temperature, the light, and the vine water status. So again, to make a long story short, the main role of a training system is to help to manage canopy and bunch microclimate, of course with cultural practices. Those 2 figures are nicely showing the effect of light and temperature on the differentiation of the latent bud. I mean on the differentiation of the future primary shoot and inflorescences. And on the left hand side, you see that you need a certain amount of light within the canopy for the latent bud to work properly in terms of differentiation of primordia of shoots, leaves, and inflorescences. And on the right hand side, you see that you need a certain temperature for this differentiation to be achieved, and the threshold, the positive threshold, will be between 20 to 35 degrees, meaning that low temperature or very high temperature could affect the differentiation of the latent bud. These 2 figures are showing the effect of respectively vine water status, expressed here measuring the pre-dawn leaf water potential and the nitrogen status of a vine. So apart temperature and light, water and nitrogen are important factors impacting on latent bud fertility. What we do call latent bud fertility is in fact the number of primordia of inflorescences which will be differentiated within the latent bud. So, why cane pruning? Cane pruning is used for varieties like Uni Blanc, for example, for which the basal latent buds, the bottom buds on the cane, are not or less fertile. So you need to increase the number of buds per vine or per square meter to increase the yield by increasing the number of latent buds, so by increasing the number of clusters for a vine, and then after, of course, per hectare. So as I already said, around flowering year 1, the bottom latent bud are normally differentiated around flowering, and you see on the figure on the right hand side that there is a gradient in terms of latent bud differentiation along a cane. Why? Because, and you see that you have a decrease in bud fertility at the end of the season. Why? It's just because at the end of the season, the climatic conditions are not good enough now for the latent bud to be able to achieve properly their formation, their differentiation. So again, it means that climatic condition, vine water status, vine mineral status matter. So this means that along a cane, when you practice cane pruning, the latent bud fertility according to the position of each buds on the cane will vary. And this variation depends on the previous year climatic and physiological condition. This slide is showing the first stages on the left-hand side of the development of the inflorescences on the primary shoot, and the second photo is showing inflorescence, one inflorescence at flowering stages. Keep in mind, and it's very important, that from bud break to flowering and fecundation, the carbohydrate reserves are crucial because the vine is living on its carbohydrate reserves, which has been refilled the previous year. Obviously, for water, nitrogen, and minerals, the roots are providing, if available, those elements, but the leaves are not functional. They are functional, but they are sink and not source. And this is why the carbohydrate reserves are very important. These are transversal sections of a flower, of the ovary of a flower. And you see that within an ovary you have 4 ovules. And as I said, just one normal seed is enough for a berry to grow normally, to develop normally. So just one fecunded ovule is enough. And again, this is a very important stage looking at yield component. This stage is part of the 70%. And this stage will determine the number of berries per cluster. So again, factors affecting fecundation, flowering and fecundation are water, temperature, wind, rain, carbohydrates, obviously, and some micronutrients like boron are important for this period for the fecundation of the ovules for many reasons that I don't have time to develop currently. So, as you know, during flowering and during the fecundation period, it's possible to get what we call coulure and milan in French, which will result by the drop of flowers or young berries, and this is due to a problem with fecundation, with berry fecundation, problems which are linked to climatic and physiological issues, and it's where and when a vine can really lose a lot of yield or future yield, of course. So apart the abiotic factors, remember that diseases can affect flowering and fecundation, flower fecundation. So diseases can affect the 70% of the yield component. So when all berries are fixed to the cluster, then berry growth, berry development is starting. The first stages is the green growth stages, and you have a sort of lag phase, and then you have from veraison onwards another growing period. And this curve, which is very classical, is coming from population of berry. We are working a lot on a per berry basis, and on a per berry basis it's a bit different. Anyway, the main factors which will now affect the volume of the fruit will be water and nitrogen, to make a long story short. We all know that the seed number is important for the volume of the fruit, but it's not a linear relation, meaning that you can have the same berry fresh mass for berries having 1, 2, or 3 seeds, and this is just showing the important effect of other factors as water, nitrogen, cell numbers, we don't really know about that one, etc. So from veraison onwards, as I said, the berry is loading sugar and water, and normally on a per berry basis, the volume of the fruit will double from the onset of veraison up to the plateau of berry sugar accumulation. The plateau of berry sugar accumulation is reached around 26 to 30 days after the onset of veraison. And it's important to keep in mind that from the plateau of sugar accumulation, a fruit will start to lose water, because as an hypothesis, we think that the phloem now is no more functioning. The xylem was perhaps no more functioning from veraison onwards, but from the plateau of berry sugar accumulation, the phloem as well is not functioning anymore. And then this is where and when the fruit starts to lose water. And the ultimate stage of water loss is berry shriveling. And this is, of course, very important in terms of yield. Two other points: from the plateau of berry sugar accumulation, and because the fruit is not connected, very well connected to the vine anymore, even if you are under irrigation, it will be very difficult to compensate the loss of water with irrigation. But you have to keep in mind that it's complex. Why? Because you have what we call the asynchrony of berry development, meaning that within a cluster, all the fruits will not reach the plateau at the same date. So this is something which is very important in terms of yield component. It's part of the 30%, and we are doing a lot of studies on that topic. And the Australian colleagues are studying what we call the programmed cell death within the pulp of the fruit, which is as well part of yield loss in terms of berry shriveling and berry water loss and berry shriveling. So, to summarize, you see with this slide that speaking about water, for example, in fact, a vine needs water from pre-bud break to post-harvest. Why from pre-bud break? Because you need to refill the soil water content to have a proper latent bud development and to keep a proper fertility, latent bud development, including the inflorescence development, etc., as we already saw. And then why post-harvest? Because you need to refill the carbohydrate reserves. Keep in mind that I spoke about the plateau of berry sugar accumulation, which is reached 30 days after the onset of veraison. And keep in mind that the carbohydrate reserves starts to be refilled from the plateau of berry sugar accumulation and not only from post-harvest. Anyway, the vine physiology, the vine water status, post-harvest is very important to contribute because you need active leaves to contribute to refill the carbohydrate reserve. So, thank you very much for your attention, and if you have any questions, it will be with pleasure that we will try to answer to them, or I will try to answer to them, because my colleague, Dr. Anne Pellegrino, is not with us currently. Thank you very much.